Okay, let's begin with another problem of LeetCode. But this problem is the problem number 42. It is going to be a hard question. When I say it is hard questions, that means you have to watch this video at least 3 times. First time to understand the problem statement, second time to build the logic, third time to get in-depth understanding how the logic works rather than remembering or by hearing. Let's understand the algorithm. The very first thing, understand the problem statement. It is very important that trapping water is something different from holding the water between two walls. There is a similar problem in the LeetCode. That was an easy question. Let's understand it better with example. Let's consider my data is 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1. This is the height of the wall and the width, it is fixed of 1 unit. So what it represent is, when I say 0, this is my height of the first wall, this is second height, this is third height. So let's draw the picture. Okay, consider this is my x-axis and y-axis. The first wall is going to be, let's consider 0 height, so I don't have any height. This is going to be the first, and the second is 1. That means this is, let's consider this is 1. Okay, this is a filled wall. Second is, consider this is my index 0, 1, 2, 3, 4, and so on. Now we have completed 0 index, 1 index, 2 index is 0, and the third index is 2. Let me write the height of the wall is 0, here it is 1, again 0, again 2. Now next is 1, 0, 1, 3, 2, 1, 2, and 1. Now if I say 1, this I will say is 1, again 0. Okay, again this is 1, now it is of 3. Okay, now again it is 2, this is 1, again it is 2. Now if I pour the water from the top, so water will be held in which area? Let's consider this is my water, so it will be held here, here, up to here, because the minimum height will be 2 in between this one and this one and here. So how much amount of the water it will be holding? Let's consider this is height 2, height 1. So up to this height the water will be held in between this wall and this wall. So what is the unit of the water it is holding? 2 minus 1, which is 1. So 1 unit of the water here, 1 unit of water here. How much amount this is? Let's consider this is 1. Okay, this is also 1, this is 2, this is 1, and this is 1. So total will be 1 plus 1, 2, 2 to 4, 5, 6. So the answer will be 6. Now this is about the problem statement. Now, how to solve this problem? There are many strategies. First, we'll see the brute force, which is not an feasible solution. Since we don't want to go for any square complexity, there is a better approach which is based on prefix. Here, the height of the wall is very important. For example, let's say this one. So, what is the height, maximum height on the left side? It is 0. Maximum height on the right side is 3. So with these two heights, the max height on the right side, I will say R max, and left side I will say left max, based on which position I am standing. For example, I am standing here, the right max is 3 and left max is 0. If I stand here, that means the left max height is 2 and the right max height is also 2. So it depends on position. So best strategy is iterate one by one and find what is the max with reference to the current position and what is the max on this one. Why it is so important? Because it is based on one formula. First we'll see what is that formula. The formula is, let's consider the max water. Okay, I will say water at index. Water at index I will be, actually it is minimum of two values. What are those two values? The height on the left, okay, this is going to be left height max comma right height max minus, it is going to be height of the wall at position I. So at every position I am going to subtract the height and I am going to take at current position what is the max left and max right. Out of these two values I am going to take a minimum value. With this minimum value I am going to subtract the height. Make sure that this should not be a negative value, it should be positive value. Like this, every index of the wall, find the water amount and keep on adding this one. Let's consider, go back, okay, at this position, what is the right max? It is of 3. What is the left max? It is of 0. So at this position, wall, left max is 0, right max is 3. Now, if I come here, then the left max will be 1 and right max will be of height 3. This is what I was talking about, R max and left max at this position, okay. So for each position, find right max, find left max, get the minimum of these two minus the height. Why I am subtracting minus is because the difference of that will be holding the water. That's the reason this is the formula. Find the max on the left side, find the max on the right side, take the minimum value out of these two, then subtract with the height. Let's understand with the same example here, okay. Now I'm going to exercise with that formula, okay. Now at this position I am here, okay. What is the max on this one is 3 and max on the left side is 0. So the minimum will be 0. 0 minus 0 will be 0. So here the answer will be, let me write in green, okay. Here the answer will be 0, okay. Now move to the next wall, which is of height 1. What is the left side maximum height of the wall? It is 0. On the right side it is 3. So the minimum between 0 and 3 is 0. Then subtract minus 1. The value will be negative. So I am going to ignore this value because it is no more positive values, okay. I am ignoring here. Now jump on this 0, okay. Now on this 0, left will be max 1, right will be 3. So between 1 and 3 minimum value will be 1, okay. With this value minus height 0, it will be 1. So here the answer will be 1. Okay. Now move to the next wall, this wall. Okay. Now the max on the left will be 1, right will be 3. Out of these, minimum is 1, 1 minus 2. 1 minus 2 is negative value, so I am ignoring this one. Okay, so let me draw with the same line. Okay, I am ignoring. Now move to the next wall, which is 1. What is the max now? No more, it is 1. It is of 2. And what is the max on the right side? It is 3. Now out of these two max, which is the minimum value? 2. Okay, 2. With this 2, subtract the height of the wall. 2 minus 1 is 1. So the answer will be on this wall. I am holding 1 unit of the water. Am I right? Yes, it is holding 1 unit, right? Now move to the next wall, which is of 0. What is the max height? It is of 2. What is the max height on the right side? It is of 3. Out of these two heights, 2 and 3, which is the minimum height? Which is 2. 2 minus 0, it is 2. Can you see the pattern here? It is 2. Am I right? This is 2 unit of water. This is 1 unit of water. This is 1 unit of water. Are we going in the right direction? Yes. We can observe like in this pictorial representations. Let's move on the next wall. Okay, which is of height 1. What is the max height? It is of 2. What is the max height on this one? So we should take the minimum height, which is 2. 2 minus 1, which is, out of these two, minimum is 2. 2 minus, subtract the height. Once you subtract the height, then only you will be getting the amount of the water it is holding on top of that wall, which is 1. 2 minus 1 is 1, which is a positive value. That's the reason this is 1. Now let's move on the next wall. On this wall, is there any water holding on top of this one? No. Let's prove this one. Okay, right now I am at this position. I index is this one. What is the max height? It is of 2. What is the max height on the right side? It is of 2. So minimum out of these two value will be 2. Okay, 2 minus 3, it is minus 1. That means this is negative value. I am going to ignore the negative value. In other word, I can say nothing is being held on top of this wall. For example, on top of this wall, yes, there is a amount of the water which is 1 unit it is holding. But since the height of the wall is somewhat bigger, so it is not holding any water. Now jump on the next wall, which is 2. Right now I am at this wall. What is the max height? It is of 3. What is the max height on the right side? It is 2. What is the minimum value on this one? Which is 2. Now this 2 I am going to subtract with 2. So it will be 0. So this will be holding 0 amount of water. Now jump on the next wall, which is 1. What is the max height? It is 3 on the left side and 2 on the right side. What is the minimum of these two values? Which is 2. Now this 2 I am going to subtract with 1. 2 minus 1, it is of 1. Yes, it is holding 1 unit of the water. Now jump on the last wall. Okay, what is the max height on this one? Which is 3. What is the max height on the right side? It is 0. So what is the minimum value? It is 0. 0 minus 2, it is going to be a negative value. That's why I am ignoring the amount of the water it is holding. Now add these values. Okay, this is 0, this is nothing, this is 1. Yes, it is 1. But the formula also 1 and pictorial presentation also it is holding 1 unit of water. 1 plus 1 plus 2 plus 1 plus 1, which is going to be 6. So the final answer is going to be 6 unit of the water holding if I'm trying to pour the water on top of all these walls. So nothing will be held here because there is no supporting wall where it can hold the water. That's the reason I'm putting 0 here, 0 here. So the amount of the water will be held on this positions. This is how we can solve. But the brute force, this is going to be a brute force which is not a feasible solution, especially if you are going to solve the problem with DSA in interviews. Interviewer is not interested to see a solution having n square complexities. So you have to solve in an efficient way. There is one efficient way, even though there are many efficient way, but we are going to see the very first efficient way, which is called prefix. This formula required left max and right max on every I position. The I position is the height on which we are currently. So no need to find the height every time. Rather than that, I am going to store in a array which is called prefix array, so that I can utilize this array multiple times. This is called prefix methodology. How we can do this is, let's consider I have the array. Okay, so I'm going to write in different colors. So what all the two arrays? First is, let me copy the array which is going to be a data. Okay, this is my data. Okay, along with the formula. Now I need the length of the array is 12. This is my length. I will mark as n. Now with this one I am going to create two arrays. What is that? Array name is left max array of size 12, and on each index I am going to store the max height. What is that? Is the reason it is called the prefix. For example, this one, what is the max height on the left array? Since this is position 0, I am going to store as it is 0. Now, one position, what is the max height? It is of 0. Z at this position, index 2 position, what is the max height? It is 1. That's the reason I am storing all the max in single iteration, which is required only n. Okay, and in the same way I'm going to find a right max. So again one more iteration, so it is no more going to be n square, it is going to be n plus n complexities. Now let's start. Okay, at this height, what is the max? At 0, it is going to be the first number. Okay, same 0 on the index. Let me write the index in different position: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Now 0 position, yes, the max length is of 0 only, because there is no wall on this one. So I can't say any wall is there which is bigger than this index. That's the reason I always copy at 0 index. Now at 1 index, only one wall was on the left side which is of 0. So I'm putting at 1 index 0. Now go to the second one. There are two walls here. What is the max height? Max height is 1 at this position, because it is having only one wall on the left. So I will mark as 1. Okay, in the same way, now move on the third one. Third one, the left max is again 1. Now move to the fourth index. What is the max height? Now it is of 2, because on this position, fourth position, okay, there are 4 walls, but the max is 2. So I'm going to store 2 on this one. Now at fifth positions, at this position, what is the max? It is still 2. So I will take as 2. On sixth position, still 2. Seventh position, still I can say at this position, still the max is this one 2. The same position I am storing here, but on the eighth position, now on this one, the max is no more 2, it is going to be 3. So on this index, I will say when I am coming to 8th index wall, the max will be 3. Now continue for this one. Okay, 8 and 9 it will be 3, and 10 it will be 3, and 11 it will be 3. So this is my array for left max. In the same way, I will say a right max array. Now on the right max array, I will take another color. Okay, so consider the right at index 0. What is the max height? Instead of this one, can I say on this one, on this last index, what is the right max? Is there any wall here? No. So can I say the right max on this 11th index is the same height, right? It is going to be n minus 1, in the same way how we have taken for the left max. Okay. Now start from the 0th index. The 0th index, the height, max height is 3. I will say this is my 3. On this wall, 1 index, still it is, I will say 3. Now second index, still it is going to be 3. Third index, right now we are here, the right is, still it is 3. I can say yes. Fourth index, still it is going to be 3. Fifth index, still it is going to be 3. Sixth index, still it is 3. Now seventh index, what is the max height? Right now I am here, what is the max height? It is now 2. Eighth index, it is 2. Okay. Ninth index is still 2, but the 10th index, now the max height at this position on the right side is 1. There are two approaches. The last element, either you can take the height of the last element, or we can say 0. Just like we have taken the first element as 0. Even if we take the first height of the wall, it is fine. Last height of the wall, it is fine. Or you can say nothing is there on the right side, you can mark as 0. Now with just 2 iteration of n complexity, we got predefined left max and right max. Can we utilize this one on finding the minimum and water? Now we can add the formula. At index water 0, I know the left index is 0, right index is 3, minimum is 0. Subtract with the height of this one, then store amount of the water. In the same way, go for this one. I know the value of left max, no need to again calculate repeatedly for every index. I have predefined data in the left max and right max. Substitute these values and find the minimum out of these values. Subtract from the respective index. For example, right now I am index 5, minimum is 2 or 3, which is 2. At index 5, subtract with 0. This is amount of the water. In that way you need to keep on adding and get the result. So this is the way we can solve efficiently with a complexity. I can say the time complexity will be order of n. It is no more repeated. Okay, but the exact order is, this is 1n, 2n and For the water on each wall, I am going to iterate one more time, which is going to be 3n. But since this is fixed values, so I am considering the complexity as order of n. Now, from programming perspective, how we can do is, let's consider I'm starting with a I can say left max array, okay, and initialize with 0. How many times I need to initialize? The n len. In the same way, I can say what was the first element? Left max of, consider left max of 0. Either you can consider 0 or better consider height of the same wall 0. Okay, now you need a for loop iterate the index in the range. Okay, this is I'm going to populate the left prefix, okay, with the height I can say in the range of 1 to till the length. Okay, now populate left of this index. What is that index? I index will be the max of either left of previous value or the current height of I, either the previous value or the current height, whichever is minimum store into the ith index. Keep on repeating this one for left index. Okay, this is for left index. For the right index, repeat the same for loop. Okay, now either you can go in the reverse order or in the forward order. Okay, and store into the right array. Now there is, we required one more for loop for water. So initialize the answer as 0. Okay, for I. Now complete a range till n. I need to repeat. Okay, now what will be the water? Water equals to water plus equals to, what was the formula? Min of left max at I index comma right max at I index. Now this value we have to subtract minus with height of the wall. This is the formula. I hope you remember this, right? This is take the minimum values out of left max, right max, then you subtract with height of the wall. Keep on adding this one into water and finally return water. This is going to be the amount of the water, the unit of the water it is going to hold if we pour the water on top. That's why it is called tapping the rainwater. I hope you understand this one. There is one more solution which is going to be a better solution. We'll see in the next video.